this is the problem key for the problems that had multiple possible chains. I need to do this in color, and the other system that I use doesn't have any color capabilities. So this is problem 1N. Okay, so here's my molecule, and now we've got to locate the longest continuous carbon chain. So in this case, let's say that the longest continuous carbon chain, as one possibility, let's write that in blue. And so I've got a 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon chain. So that would be a nonane chain with 1, 2, 3, 4, 5 substituents. Okay, and are there any other nonane chains in this molecule that I could draw? I think there's one other one that we'll put here in orange. And now I can't see my little dot because it's orange. So 1, 2, 3, 4, 5, 6, 7, 8. Now, nine. Sorry, that's a 9 carbon chain. So the orange one here is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this orange one is a nonane also, but how many substituents does it have off of the orange? 1, 2, 3, 4. Good. So that one only has 4 substituents. So clearly then the blue one, the blue chain, is the one that I'm going to use then as my longest chain. So I'm going to then use this chain to go ahead and write my longest continuous carbon chain. So down here, let's not even bother with that. Let's just go down here. Let me rewrite the molecule. And so my longest continuous carbon chain is going to be this one. All right, so we only have one possibility. What do I have attached? I got a chloro group. I got an isopropyl group, or what I would call then the 1-methyl ethyl group. So either one of these I can use. Down here I have an isopropyl, or 1-methyl ethyl. And then I've got a beta-bromo group, and then I've got a methyl. So in terms of the numbering scheme, then I pretty much have to go left to right because I encounter the chlorine at carbon 2. If I went from right to left, I would encounter the methyl group at carbon 1, 2, 3, 4. So clearly this is the correct numbering scheme. And so this is going to be a nonane. And just to make life easier, I'm either going to call these 2 isopropyl groups or 2 1-methyl ethyl groups. I'm not going to mix and match on this one. So that means that I'm either going to have a 3, 4 di isopropyl group, or a 3, 4, oh, isn't this fun? You know what, we'll just call it. We won't worry about the exact. You can learn about that in a later class. We'll just call it a di 1-methylethyl. Okay, so either got a diisopropyl or a di 1-methylethyl group. Okay, and then a bromomethyl and a chlorine. So if I'm writing the name of this out, one possible name is 5-bromo, 3-chloro, 3,4-diisopropyl, 6-methyl nonane. Now the diisopropyl rules I'm still alphabetizing on I because the di, tri, tetra don't count unless they're in brackets, which in this case they're not. So this is one possible name. The other possible name would be 5-bromo, 3-chloro, 3,4-di 1-methylethyl, nonane. So again, alphabetizing on the B, the C, and the M. Okay, so there's two possible chains for this molecule, but only one gives more substituents. So we use, in this case, the blue chain that I did above. And so the final name is either 5-bromo, 3-chloro, 3,4-diisopropyl, 6-methyl nonane, or 5-bromo, 3-chloro, 3,4-di 1-methylethyl nonane. Problem O. Let's draw out its structure. Okay, so I got a chlorine and then these other groups. So how many longest chains do I have for this molecule? Well, let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, these two isopropyl groups here and here, it doesn't matter then which chain I start into, so they're not going to give me a different result, nor will any starting or having the chain contain all three of these methyl groups. Any of those three would be the same molecule. So looking at this, here is, let's try this as one carbon chain. 1, 2, 3, 4, and 5. Then 5, 6. Okay, so this was a tricky question in the fact that you can't look at the chlorine as if it was a CH3 group. So I've got 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. No, I still got 6 there. Let's come down here and get a red. So let's try another chain. Let's go 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. So the red chain is 6 carbons. So it's a hexane. And how many substituents does the red group? It has 1, 2, 3, 4, 5. So it's got 5 substituents. The blue chain had 6 carbons as well, so it was a hexane. And in this case, the blue chain has 1, 2, 3, 4, 5 substituents. Oh, wait. What did I just do? Wait, what was I thinking? The blue, sorry. The blue chain has 1, 2, 3, 4 substituents. Okay, so the blue chain has 1, 2, 3, 4 substituents. The red chain has 1, 2, 3, 4, 5 substituents. Great. So let's use the red chain. So in other words, let's draw out the structure again. And now let's use the red chain. Numbering scheme. Going bottom to top, top to bottom. Going from the bottom, I encounter a methyl group at carbon 2. Coming from the top, I encounter 2 methyl groups at carbon 2. Therefore, the numbering scheme is going to be this one. There's my numbering scheme because I get 2 methyl groups. So what do I have? I've got a 2, a 2, 5, trimethyl. And then at carbon 4, what do I have? At 4, I've either got an isopropyl group or a 4, 1-methyl ethyl. And then on carbon 3, I've got this one's a little tricky, I've got a 2-chloro ethyl group, and that's attached to carbon 3. Okay, this group right here is an ethyl group. The attachment point has to start carbon 1, so it's got the chloro group at 2. So this is a 3,2-chloroethyl group. So there's 2 possible names for this molecule. I'm going to alphabetize on M in trimethyl, I for isopropyl, M for the methyl there, and C for the chloroethyl. So one possible name for this would be 3,2-chloroethyl. Then 4-isopropyl. Then 2,2,5-trimethyl hexane. Okay. That's one possible name. Now using the 1-methyl ethyl, and remember 1-methyl ethyl comes after the trimethyl. So in this case, the other possible name would be 3,2-chloroethyl. Then a 2,2,5-trimethyl. And then the 4,1-methyl ethyl. Hexane. So either of those 2 names would be correct. Two down. Problem P. Problem P looked like this. Okay, how many different chains do we have here? Well, it looks like I got a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So here's my two possible chains that I'm looking at. 1, 1, 2, 3, 4, 5, 6 for the red. And then one, two, 1, 2, 3, 4, 5, 6. And I think that's it. So the question is, looking at the blue chain, I've got 1, 2, 3, 4. So the blue chain has 6 carbons, so it's going to be a hexane. And I've got 4 substituents. The red chain had 1, 2, and then this whole thing as 3. So the red chain has 6 carbons. It's also a hexane. The problem was that it only had 3 substituents, okay, off of that red chain. And so therefore, I'm going to go with the blue chain. And so I'm going to rewrite this molecule out. So there's my molecule. Now let's go ahead and superimpose the longest chain with the most number of substituents. So what do I have? I got a bromo group. I got a methyl group. I got another methyl group. And that down here I have this one's different, a 1 chloroethyl group. Okay, so I've got a 1 chloroethyl group because again, here's my attachment point, carbon 1, carbon 2, ethyl, attached to carbon 1, chloro. Okay, so now I got to figure out my numbering scheme. And I'm going to number this from right to left, 1, 2, 3, 4, 5, and 6, because I've got 2 substituents at the carbon 2. If I tried to number from left to right, I wouldn't encounter a substituent until carbon 3. So there's my numbering scheme. So that means I've got a 2 bromo, I've got a 2,4 dimethyl, and then I've got a 3, 1 chloro ethyl. Okay, and so therefore, that's my 4 substituents. So now I can go ahead and alphabetize on the B, the M, and the C. So only one name for this molecule, 2 bromo, 3, 1 chloro ethyl, 2,4 dimethyl, hexane. That's its final name. Okay. Problem R. Okay, let's see if we can find the correct longest chain in this molecule. So what do I have? I've got a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, so here's my 2 8 carbon chains. 1, 2, 3, 4, 5, 6, 7, 8. So the blue is an octane chain, and it has 1, 2, 3 substituents. Okay, let's go to red, and let's find the other chain. So I'm thinking 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7, 8 for the red chain. And how many substituents does the red chain have? 1, 2, 3, 4 substituents. So the red chain is still an octane, but now it has 4 substituents. So that's the one I'm going to use. Okay, so let's rewrite that. Okay, and my red chain would go like this. All right, there's my 4 substituents. So I'm going to number down here from 1, 2, 3, 4, 5, 6, 7, 8, because that gives me the first substituent at carbon 2. If I numbered from this end, I'd end up at carbon 4. Okay, so what do I have? I've got a 2, 3 dimethyl. On carbon 5, I have an ethyl group. On carbon 4, what do I have? Carbon 4 is either an S-butyl or a sec-butyl, or it is a, if I number this, a 1-methyl propyl group. So 2 possible names for this molecule, depending on whether I use S-butyl, 1-methyl propyl, alphabetize the B for sec-butyl, M for methyl propyl, M for dimethyl, 5 for ethyl. So 2 possible names here. So our first possible name is going to be, well, let's go ahead and take the S-butyl. So 4 sec-butyl, and I know I'm using the S and the sec interchangeably. That's fine. What's next? 5-ethyl. After that, the methyl comes before methyl propyl, so it would be 2, 3 dimethyl. That didn't make any sense because the methyl propyl isn't used now, so it's 2, 3 dimethyl because I'm alphabetizing on M. Octane. So there's the first name. Now let's use the 1-methyl propyl. The other possible name is this, 5-ethyl. 2, 3 dimethyl. 4 1-methyl propyl. 1-methyl propyl, octane. So either of those 2 names is correct. And again, methyl is alphabetized before methyl propyl. Good. Last problem. Problem U. Okay, for problem U, I have the bromine attached to the carbon. So the question is, what is the longest continuous carbon chain in this molecule? So I'm looking, I got a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. So I got 2 8 carbon chains in the molecule. The red one, so there's 1, 2, 3, 4, 5, 6, 7. We'll call that 8. So there's my 8 carbon chain. That 8 carbon chain, that's an octane chain, and how many substituents does it have off of it? The bromine, the isopropyl, the CH2Cl, methyl, chloro, and methyl. So 1, 2, 3, 4, 5, 6. So that gives me 6 substituents. Go to another chain. The other possible chain was this one. 1, 2, 3, 4, 5, 6, 7, 8. How many substituents there? 1, 2, 3, 4, 5, 6. Great. So we've got 2 possible ways to name this molecule. And I'm not going to bother to look up the tie-breaking rules. I'll just avoid this problem in the future for tests. I didn't think I could actually come up with one of these problems, but apparently I can. And here it is. So what is an acceptable answer? Well, there's 2 possibilities in this case. Let's use the red longest chain first. I'm just going to rewrite this molecule. All right, here's our longest continuous carbon chain. So numbering, I have no choice. I have to number at the end closest to the first substituent. It's kind of funny, but when you have halogens like chlorine, bromine, iodine, if those are attached to the first carbon in a chain, then you automatically are going to start numbering there. So 1, 2, 3, 4, 5, 6, 7, 8. So there's the 8 carbon chain that way. What do I have? I've got either an isopropyl or a 1-methyl ethyl, either one. Down here I've got a bromine attached to carbon 1. This is a chloro methyl group. And then I got a chloro group. And I got 2 methyls. So I got a 5,7 dimethyl. Great. So now let's put the 2 names to this molecule. What would it be? Well, I've got a chloromethyl, I've got a chloro, I've got a bromo, and then I've got an isopropyl and a dimethyl. So it's going to go bromo, chloro, chloromethyl, isopropyl, dimethyl. So 1 bromo, 6 chloro, 4 1 chloromethyl. The 1 is actually kind of unnecessary because if you've got a chloromethyl group, there's only one place the chlorine can be attached to. But I'll put it in as a 1 chloromethyl just to be consistent. Then a 3 isopropyl and a 5,7 dimethyl octane. Writing it as a 1-methyl ethyl group, the 5,7 dimethyl is going to be 1-methyl ethyl, so the other possible name is 1 bromo, 6 chloro, 4 1 chloro methyl, 3 1, oops, sorry, that's not correct. Right, getting ahead of myself. I just said the methyl came before the, so it's a 5,7 dimethyl, 3 1 methyl ethyl, octane. So these are the two possible names for the red longest chain that has the 4 substituents. I'm sorry, 6 substituents. So I got it 1, 2, 3, 4, 5, 6. So there's my 6 substituents. Okay, so either one of these two names would be correct if you chose the red longest chain. Okay, what would the blue longest chain look like? How many different names can I come up with for that? Well, I'm going to come over here and I'm just going to draw it from scratch. Okay, and so the blue longest chain we said was, I believe, this one. 1, 2, 3, 4, 5, 6, 7, 8, with 1, 2, 3, 4, 5, 6 substituents. So what substituents do I have here? Well, first of all, I've got a methyl. This group is a 2 bromoethyl. I still have a 1 chloromethyl. I've still got a chloro. And then I've still got my methyls there. So this one's going to be a trimethyl. Now, how do I number this? If I number up here, I'm going to encounter a methyl group at carbon 2. Down here, I'm going to encounter a methyl group at carbon 2. So since I've got one substituent each and they're the same, I'm going to break the tie by moving on. So now when I come down here, I've got a 2-bromoethyl versus over here a chloro. The 2-bromoethyl comes first alphabetically, so therefore I'm going to number it like this. Okay. And so in this case, what do I have? Well, let's combine all the methyls up. So I'm going to have a 2, 5, 7 trimethyl. Then I'm going to have a 3, 2 bromoethyl. I'm going to have a 4, 1 chloromethyl, and a 6 chloro. So 1, 2, 3, 4, 5, 6. There's my 6 substituents. Alphabetization M, B, C, C, chloro coming before chloromethyl. So only one name possible for this chain. 3, 2, bromoethyl. Then a 6 chloro. 4, 1 chloromethyl. 2, 5, 7 trimethyl octane. So if I use the blue chain as my longest chain, then I would have 3, 2 bromoethyl, 6 chloro, 4, 1 chloromethyl, 2, 5, 6 trimethyl octane. And so that would be the name if I was to write the blue chain. And the problem again here is there has to be a tiebreaker that as to which chain I would draw for this molecule, whether I would draw the blue chain or the red chain. And if I get overly ambitious, I'll bring to class the stone tablets that have the IUPAC rules carved into them by the members of the Pure and Applied, the International Union of Pure and Applied Chemistry, who sit on a mountaintop and dictate these rules, because only one of these two names is correct. But I will have to look that up for Friday. Okay, so the problem here is that the other method that I used to write out homework keys doesn't have color, and these problems needed color.